All right. So from here, to kind of help you in terms of figuring out where to plot points on your graph and kind of how things are going to look. What you normally have, what you're used to doing is whenever I had a student yesterday ask me, well, how do you know where to plot? You're like, I plotted a couple points, and they're like, well, how do you know that? How do you know where those points are going to go, like right off the bat and automatically? Okay, well, I've been doing it a long time, so I just know the pattern. Okay, so to help you kind of take things from the vertex so you know kind of how you're going to go and how to, so like you don't always have to find the y-intercept. While finding the y-intercept is always an easy value to find, in some cases you're not going to know exactly where it is. Like if it's off the graph, if it was like at a positive 11. Okay, there are some graphs that obviously could be at a lot of different places depending on how it moves left and right, up or down. You know, it may, or how it's stretched or shrunk, things like that. You may never get there as far as your negative 10 to positive 10 graph, okay, in terms of your x and your y. So here is just your regular parent function of just y equals x squared. So where there is no manipulation to it. Okay, so if there's no manipulation to it, it's just going to be all of your values that are going to be perfectly squared. Okay, so if we go to the table and everything starts at 0, and I'm just going to look at the positive numbers instead of the negative because it just repeats themselves. What do you notice from from 0, because the vertex is, like, this is my vertex. How much did it go up here? Went up 1, right? How much did it go up here? 3. What about here? 5. How much do you think it's going up next? 7, and then 9, and then 11, right? So for every one step to the right, so from my vertex, there's no manipulation here. Okay, so from 0, 0, the first step or the next point on my graph, I'm basically going to take one step to the right, and I'm going to take one step forward. Okay, the next step is going to be one step to the right, and then how many steps forward? 3. Okay, the next step is then going to be one, basically slide to the right, and then what? 5 steps forward from that new point. Okay, I'm always leaving from that last point. Whereas if I do the same thing, but now I'm going to add another graph or another point. If I have 2x squared, okay, 1, okay, so the original one is the blue one. The new one is now the red one. This is what's called a vertical stretch. Okay, it pulled my values higher. Okay, it didn't push anything in, it pulled them up. Because I'm still going to take one step to the right, but I'm going to take more than just one step forward. Okay, every time, whenever I have a quadratic, if it's a vertical stretch or a shrink, I'm always taking one step to the right, or one slide to the right. Okay? It's a matter of how many steps forward that I go from there, or backwards, depending on if it's going negatively or not. If you look at the table here, where those values are in red, still at 0, 0 being my vertex. So before it went up 1, it went up 3, it went up 5. I'll go from there. Remember, this is still the vertex. For the values in red, how much did it go up here? How much did it go up here? How much did it go up here? Do you see a correlation with this was y equal to x squared. The blue, or the red one, excuse me, was y equals 2x squared. Do you see a correlation with the values that we have that are in black versus the ones that are in green? What did we do? We multiplied those values by 2. So instead of my original one, okay, if you can kind of see what I'm going to do, if I stand here, I'm still taking one slide to the right. But now, instead of taking one step forward, how many steps am I going to take forward? I'm going to take 2 steps forward. Then my next step, I'm going to take 1 step to the right, and then what? 1, 2, 3, 4, 5, 6 steps forward. Does that make sense? So whatever that number that's out in front is, okay, whether it's in front of a parenthesis, whether it's out in front of a standard equation, whatever that first number is, okay, that's in front of your x squared, or it's in front of, like if I had 3 times x minus 1 squared minus 4. That first step is going to be 1 step to the right, but how many forward from my vertex? How many am I going to go forward from that first step? What number is that? 3. So if I would have 3 times whatever, okay, or what if we do it again, but now we only go like a half. I'm still taking a step to the right. So if I have kind of the other or the opposite direction of 1/2 x squared, okay, I don't remember what color that's going to be. Black. Okay. What we did was we pushed it down. This is what's called a vertical shrink. Okay? We pushed the y value down, so whenever we put it in a table, instead of taking, we still slide 1 step to the right. Your x value never changed. It's only your y value that's changing. Does that make sense? So it's only your y value that's changing. I'm still going to take my 1 slide step to the right, and then I'm going to keep always taking 1 step to the right. Okay? I always take 1 step to the right because the left side is going to be the exact same thing on the other side. But instead of taking 1 step, I'm going to take a half a step. Instead of taking 3 steps, like I did from 1 to 4 in the blue column, I'm going to take 1.5 steps that I have in the black column. Okay? Do you understand how that number in front of the x squared is going to manipulate what I do and how I take my steps whenever I graph it? Yes? No? Maybe. With any of these, okay? The easiest way, whenever you have something in standard form, is to find the axis of symmetry first and then use that to find the vertex. So to find the axis of symmetry, to find the x value in my function, or of my vertex, I'm going to take the opposite of b divided by 2a. Have you seen the opposite of b over 2a before? What's the quadratic formula? Isn't it just that part that's out in front? Okay. So remember, just like we did before, a is 2, b is -8, c is 6. So if I want to find my vertex, what's the opposite of b? Or what's the opposite of -8? Positive 8, right? Or 8. So I have 8 over 2 times 2. So what's 8 divided by 4? 2. So if I'm looking for my vertex or my axis of symmetry, my axis of symmetry is 2. Where did that 2 come from? Right up here. Okay? Whatever value you get, so my axis of symmetry is at 2. So then I'm going to have a vertical line. So go ahead, once you find something, go ahead and put it on the graph. Okay, so if I have x is equal to 2, there's my imaginary line. I have one part of my vertex. I have the 2, but I don't have the y. Now, all I'm going to do here is take this value that I got right there, and I'm going to plug it in every time I have a y. So now, to find y, plug x into the equation. And honestly, you can, if you type it in basically just like this, and you go, so y is equal to 2 times 2 squared minus 8 times 2 plus 6. If you type it exactly like that into any calculator you have, it's going to automatically spit everything out, as long as you put the parentheses around it. Okay? You can do it longhand or the long way and go 4 squared, or 2 squared is 4, 4 times 2 is 8, and go 8 minus 16 plus 6, and get y equal to negative 2. This right here is the other part of your vertex. So it's going to be negative 2 right there. Now I can plot a point. So I'm going to go over to 2 because it's going to be on that line. Yeah. So then my vertex is down here at 2, negative 2. So remember, it's going to be on that imaginary line or that dashed line that I drew. Now, we still want to know the main parts as far as what's my domain and what is my range. What's the domain going to be? Domain is always what? Negative infinity to positive infinity. Now, another easy point to find. What have we always done to find my y-intercept? What value do we plug in? 0. Now, I'm going to tell you even easier way to do it. If it's in standard form, what's going to happen if I plug 0 in right there? 0. What's going to happen if I plug in 0 right there? 0. So what's my y-intercept? 6. If it's in standard form, okay, if it is in standard form, there's my y-intercept. Okay? If it is in standard form. When it is in standard form, your constant value is your y-intercept. Your y-intercept, when the squared function is in standard form, is your c value or your constant value or your y-intercept. I think I said it just about every way I could possible. So then go ahead and plot your point there. So go ahead and plot the point of 0, 6 on your graph. Go up from the origin, 1, 2, 3, 4, 5, 6, and there's my point. So now I have another point that I can do. Because I have the one that's on the left side, I can now do the same thing and put the same value over on the right side. Now, if you're not sure about how to find the y-intercept and just look at the very last number or the constant number, then you can always plug values in. Okay, if I plug in 1, okay, so just from what we talked about earlier, from my origin, I'm going to take one step to the right. How many steps up from the vertex am I going to go? Nope. With the 2, using the 2. So the first step is always, remember I took one slide to the right, then what? 2 steps forward. So my next point, if I need another point, is going to be here and here. Same way, if I took 2 steps forward, then I went up 6. So normally I would go up 3, but now since it's a times 2, I'm going to go up 6. Okay, and I just draw my curve accordingly. Now, what's my range? Where's it go from? From -2 to positive infinity. Okay, whenever your function is in standard form, you're going to find the axis of symmetry first. You're going to take whatever your b value is, take the opposite of it. So if it's negative, you're going to turn it into a positive. If it's positive, you're going to turn it into a negative. And then divide it by whatever 2 times your a value. What am I going to multiply, or what am I going to divide it by if there's no number in front of my x squared? Just 1, right? Just 2 times 1 on the bottom side. If there's nothing there, so like on the second one where it's x squared, it's just 2 times 1 on the bottom side. Okay? Don't overcomplicate it, don't overthink it.